This unit focuses on ways to go about naming cycloalkanes. And much like with our earlier discussion of naming linear alkanes or acyclic alkanes, alkanes without a ring structure in them, we're going to be using IUPAC nomenclature as our general guidelines for coming up with names for cycloalkanes. Remember that IUPAC stands for International Union of Pure and Applied Chemistry. That's the governing body that decides globally what the appropriate names are for organic molecules so that we can communicate worldwide with other scientists about the names of compounds. So we're going to try to name today, by the end of this discussion, compounds such as the ring structure that we have shown here in the upper right hand side of the page. In order to do that, we're going to follow some guidelines, and those guidelines are going to enable us to go about naming these types of molecules. The guidelines that we'll see here very much build on the guidelines that we learned for naming acyclic alkanes. So it's assumed that you've already looked at the video material for the acyclic alkanes and made yourself familiar with that. So first off, the parent name, the last part of the name of the molecule, is going to be the name of the ring. It's going to indicate the size of the ring that we're dealing with. And you're going to identify that it is a ring and not a chain by using the term cyclo to designate it as a ring. So for example, cyclopentane is a 5-carbon ring, cyclohexane is a 6-carbon ring, etc., etc. In order to number the carbons of that parent, remember that the parent is the part that we're going to be numbering to identify where the branches come off of the chain or come off of the ring. And in order to number those, we're going to start numbering at the ring carbon that has an alkyl branch. If you're dealing with a cycloalkane that just has one alkyl branch, then you're going to number the carbons of the ring, starting at the ring carbon that has that branch. You're often going to run into situations where there are more than one branch, particularly 2 branches. It's going to be a really common situation that we run into. And so if that's the case, you're going to need to number the ring starting at the branch that comes first in the alphabet. So for example, if you have a ring that has both a methyl branch and an alkyl branch on it, you're going to start numbering that 6-carbon or however many atom ring, starting with carbon number 1 of the ring being the carbon that's bonded to the ethyl group, since ethyl comes before methyl in the alphabet. The alkyl branch names, such as ethyl, methyl, etc., are going to follow the same guidelines that we went through when we were talking about naming acyclic alkanes. So, for example, those terms like isopropyl, isobutyl, tert-butyl are still going to be fair game here and definitely something that anyone studying organic chemistry should be familiar with. So what about in situations where you have 2 branches? You've determined that you start numbering with carbon number 1 of the ring corresponding to the location where the branch comes first in the alphabet. Then how do you number the ring? Do you number it clockwise going around or counterclockwise? How do you decide how to do that? The way you decide to do that is to take the shortest route to reach the next carbon of the ring that has a branch off of it. So that's how we're going to go about naming, how we're going to go about numbering the ring of the molecule for purposes of naming. Then we're going to make our name construction much like we have for acyclic alkanes, where the parent name is the cycloalkane name, such as cyclohexane. And then we plug in these branch names, the alkyl branches, as the prefixes and indicate using numbers where those are located at around the ring. So let's take these guidelines. I'll go ahead and shrink those down a little bit, and we're going to use them to allow us to name some example problems here. So we'll go ahead and draw out a cycloalkane. We're going to see that 5 and 6 carbon rings are particularly common because of the fact that each of the carbons are sp3 carbons, which have an ideal 109.5 degree bond angle. And by making a 5 or 6 membered ring, we're going to be able to very closely approximate that ideal bond angle. So we'll go ahead and fill this in, and we're going to go ahead then and decide how to number the ring. So the ring has 6 atoms in it, and therefore we need to be making numbers 1 through 6 around the ring. We need to decide where to start on. We're going to start at one of the 2 branches. So we'll either start with this carbon shown in red, kind of in the upper right-hand side, or this one down here at the 6 o'clock position. So one of those 2 is going to come first in the prefix for the overall name of this molecule. And in order to decide which one comes first, we need to name these 2 branches. So it'd be a good time to pause for a sec and decide whether you yourself can identify what these 2 branches are called. So thinking about what the 2 branches are called, you can hit pause to make sure that you know how to name these branches on your own. And the answer to how to name these branches is that this one is going to be called an isopropyl branch. It has 3 carbon atoms in total, and it's got that iso group where the next to the last carbon of the chain has a methyl coming off of it. The one down here is referred to as a tert-butyl group. And that tert-butyl group, because we have a tertiary carbon right here, because that carbon's bonded to 4 other carbons, and it's a butyl group because there's 4 carbons in this branch in total. We can also synonymously refer to these as a 1-methyl ethyl group, following the same criteria that we did for naming these branches when we were talking about acyclic alkanes. We can also synonymously refer to the tert-butyl group as being a 1,1 dimethyl ethyl group. So either of those two terms are acceptable, tert-butyl or 1,1 dimethyl ethyl, whichever one you like. And we need to alphabetize based on those names. So we want to start numbering the carbon ring at whichever one comes first in the alphabet. So if we're going with isopropyl and tert-butyl, iso comes before tert in the alphabet, so we'll go ahead and call this iso number 1, and then take the shortest route around the ring to get to the tert-butyl group. So 1, 2, 3, on around the ring. 4, 5, 6 gives us the designation of the parent name, and that's assuming that we're using the terms isopropyl and tert-butyl to name the branches. If we were using 1-methyl ethyl and 1,1 dimethyl ethyl, we'd have to alphabetize accordingly. So let's go ahead and fill in the name, assuming that we're using one isopropyl and 3 tert-butyl. So our parent name here is cyclo. Don't forget the cyclo part, otherwise the name is definitely not going to be correct. Hexane, because it's a 6-membered ring. And then prior to that, we need to fill in our isopropyl and tert-butyl in alphabetical order, just like we did for acyclic molecules. We filled those in alphabetical order. So the isopropyl branch comes off at carbon number 1 of the ring. So we're going to fill in isopropyl. And then at carbon 3 of the ring is our tert-butyl, so -3, tert-butyl. No spaces between any of these words, just the dashes as shown. And the dashes will always separate numbers from letters. So 1 isopropyl, 3 tert-butyl, cyclohexane. And then let's go ahead and try naming this using the 1-methyl ethyl and the 1,1 dimethyl ethyl as well. So our 1,1 dimethyl ethyl is going to come second in the alphabet because it has more numbers associated with it. 1-methyl ethyl is going to come first. So let's go ahead and fill in that designation. So this is going to be a synonym for 1 isopropyl, 3 tert-butyl cyclohexane, just another way to go about referring to this. Okay, so we filled in cyclohexane. Now we're going to plug in alphabetical order our 1-methyl ethyl group. So I'm going to go ahead and put 1-methyl ethyl. And remember that 1-methyl ethyl, we're saying that all of that 1-methyl ethyl group is part of a branch. So we put that whole thing in parentheses. And prior to that, we indicate where that is located at in the ring. So outside of the parentheses, we indicate 1 dash to indicate that at position number 1 of the ring, we have a 1-methyl ethyl. So everything in the parentheses there is what's at position 1 of the ring. Then we carry on from there using a dash to separate numbers from letters. So we're going to fill in then at carbon number 3 of the ring is where our 1,1 dimethyl ethyl group is located. So then in parentheses here, I put in my 1,1 dimethyl ethyl. I'm chronically out of space here for writing these things. So 1,1 dimethyl ethyl. Close off the parenthesis to indicate that that whole group, the 1,1 dimethyl ethyl group, is all located at carbon number 3. And then immediately after that parenthesis goes cyclohexane, no space needed. So that's going to be our way of going about naming this. So let's do one more example of this type of problem to make sure that you have the hang of it. So we're going to go ahead and fill out one additional example problem here, where we'll do a ring, and we'll fill in a couple of branches off of that ring. All right, so we need to decide what the name of this is going to be. This would be a great opportunity to hit pause, go ahead and write out the name that you come up with for this molecule, and then hit play to make sure that it matches up with the name that we come up with here. Okay, So we have a 5-carbon ring. So we need to number those carbons of the ring 1 through 5. And we'll call the parent name for this molecule cyclopentane because the pentane indicates 5 atoms, 5 carbons. Cyclo indicates that those are in a ring. So cyclopentane. And we need to decide which carbon is carbon 1 through 5 of that ring. And so what we're going to do is name the branches that are coming off of the ring. This branch that we see here has 4 carbons in the branch in total. Next to the last carbon is a methyl group, so we refer to this as an isobutyl group. Butyl indicating it has 4 carbons in total in the group, iso indicating that one of those carbons is a branch that comes off at the next to the last carbon. So isobutyl, and then over here is just a 2-carbon chain. So we refer to that as our ethyl group. So we're going to plug that in as ethyl. Put these two in alphabetical order as the front part of the name. And we need to decide which carbon number each one is going to go at. The one that's first in the alphabet is going to correspond to where we mark as number 1 in the ring. So number 1 of the ring is the carbon that has the ethyl branch coming off of it. Then we take the shortest route around the ring, so that takes us this way to number 2, 3, 4, 5. And from there, we're going to go ahead and plug in the rest of the information here. So ethyl comes first in the alphabet, so it needs to come first in the name. 1 ethyl. And then 3 isobutyl, and make sure you're getting all these dashes correct and there's no spaces anywhere in here. All the words run together. They're separated only, separating letters by numbers, letters from numbers with dashes. So 1 ethyl, 3 isobutyl, cyclopentane is going to be the IUPAC name for this molecule. An alternative acceptable name, remember that isobutyl is the same thing as saying that we have 3 carbons in the branch here, and at carbon 2 is where the methyl comes off. So we could also call this a 2-methylpropyl branch. And methylpropyl is one word, even though I'm having to put it on 2 separate lines here. So 2-methylpropyl, because there's 3 carbons in that chain within the branch, and at carbon 2, there's a methyl group coming off. So we could alternatively refer to this molecule, again, going in alphabetical order with 1 ethyl, and then at position 3, we do 3 dash, and then in parentheses, we indicate that we have a 2-methyl ethyl group. And then end parenthesis, and the term cyclopentane. And that's going to wrap up the name for this molecule. So either of these 2 names that we've listed here are both totally acceptable. They're synonyms of one another. Both will accurately describe this particular molecule, telling you specifically what constitutional isomer you have, because you're indicating with these numbers where the branch comes off of the ring. The branches can come off of the ring at many different locations to create different constitutional isomers, and you want to be specifying exactly where that branch is coming off. So with that, you are good to go on naming cycloalkanes. And there are problems in the worksheet that reinforce this, so make sure that you are up to speed on going about naming cycloalkanes, and that worksheet should help you get up to speed on that.